Okay, it is recording. Hello, my name is Alan Farner. This is my very first mathematics tutorial video. So it's going to be a bit rough. I'm trying XSplit, which I've played with a little bit, but not a whole bunch. OneNote is what you see. Wait, I got to go the opposite way. What you see up there. There you go. What you see up there, and various other things like this headset and stuff. If you hear background noise, I live at a home. Family's on the couch watching a movie, and I'm here. Okay, so with the law of cosines and the law of sines, there are various things you can do to figure out triangles. But there's one case that's a real pain in the butt, and that one is the ambiguous case. And in the ambiguous case, you have two sides in an angle, but it's not side angle side, it's side side angle. And you can use the law of cosines and the law of sines to do it. I just find the law of cosines to be a wee bit messier. And what we're going to do is we're going to use the law of sines in order to do this. The first thing I think you should do, we do have dogs, the first thing you should do whenever you go to work on a problem like this is write it out like you can see on the screen right up there right now, as I keep pointing, right up there right now. You should write it out. So I like the way Indiana University East does when they say you show work. Given, what are you supposed to find? And then you give the solution path. It may seem like wasted space, but it really will help you out. The second thing is you should always draw it. So let me put the thing is, clearly you don't know. Let's see if I can find it. Let me grab the thing here so I don't have to do it by hand. There you go, copy that, put it there. Oh, that's nice. It just got the label there. Let's try this again. And delete, told you this the first time. There we go. I think if I drag this corner here, I can make it bigger. You want to draw out the triangle. Now, you can go ahead and say to me, hey, Alan, we don't know what the sides are. Don't worry about it. Go ahead, draw it out. Draw what you do have. Because, like, for instance, in the ambiguous case, there are three possible things. Number one, there may be no solution. Number two, there may be a single solution. Number three, there may be two solutions. And because of that, you can't really draw out the final one until you've actually done the work, but you want to draw what you can. So you can see with the problem that we have here right now, and this is the standard layout of a triangle. You're going to see other things, and just try to get your mind around the fact that just because it's not laid out the standard way doesn't mean you can't use the rules. You just have to slow down, still draw your triangle. We're going to do one like this. And by the way, I haven't done the answer to this. I made it up kind of based on something that I saw in an Indiana University discussion group that's part of the trigonometry course that I'm taking right now. So I'm not sure what the answer is, but we're going to double check it with a handy tool afterward. So take a look at this. You say to yourself, what do I know? So right now, I know for a fact, and let me make sure I'm able to draw here. Just a second. Oops, try again. I know for a fact that A is equal to 10. I know that B is equal to 12. And I know beta, the angle beta, is 40 degrees. 40 degrees. So the first step, again, always is to basically put your information down and draw it down. So what we're going to figure out is what C is. But the first thing that we have to do actually is figure out, we know we have beta at 40 degrees, but we need to figure out what A is. And that's where things get a little interesting. Is A one angle or is A possibly two angles? And A is going to be affected, obviously, by how C interacts. So the first step is we're going to use the law of sines. The law of sines is something simple. And you can, what you put on top or bottom basically has to do with what you're looking for. If you're looking for the sine, then you put the sine on top. If you're looking for the length of the side, you put the length of the side on top. But basically what it says, if we want to figure out the angle alpha, okay, so we want to figure this out. If we want to figure this out, we say that sine of alpha is to A as sine, I never know how to do beta correctly, is to B. Does that make sense? Sine of alpha is to A as sine of B, a beta is to B. And so right now, if we fill that out, we can say sine of alpha is to, what is A? You know that A is equal to 10. That is equal to sine of beta, sine of 40 degrees to 12. This is where it kind of gets interesting. So if we take that, we can say that if we want to know what sine of alpha is, we can say sine of alpha equals 10 sine 40 degrees over 12, right? Because what we're going to do is going to multiply both sides by 10 in order to get rid of the 10 on this side, right? So we've got sine of alpha is 10 sine 40 over 12. So let's go ahead and take a look at that. And this, by the way, based on this, we're going to know whether we have a solution or not. It's a little early otherwise. So I'm going to take out my handy TI Inspire CX2. So basically what we end up with is something that's approximately, let's go 0.535656634. And there are three possibilities when we figure out this sign. Number one is it could be greater than 1. And if that's true, then there is no solution because sine can never be greater than 1. The second option that we have is that it equals 1. If that's true, then it's a right triangle. And there are easier ways to figure things out once you know that you have a right triangle. And then number 3, it's less than 1, which is our case right here. Then we're going to find out that we have 1 or 2 solutions. So how do we deal with that? Basically what you do is you've got to do a inverse sine -1 of what we just found out right there, right? We got to sine -1 and see what our angle comes up, and then we're going to do a test, okay? So that's going to get, what we're going to do is we're going to figure out what alpha 1 is. So alpha 1 equals sine -1 of what we got, basically the sine, right? Because we're trying to reverse it. So let's go ahead, and I'm going to be lazy and not write it. Well, we can do that. So let's go ahead and go at least to 6, 5, 3, 5, 6. Let's go with 6 just so that we have it there. And let's figure out what alpha 1 is. To make this easy, we're going to leave it without much precision. Okay, so if we do that, alpha 1 equals, we're just going to say it's 32 degrees. Okay? So alpha, the first thing we calculate for alpha based on this is 32 degrees, which, by the way, makes a lot of sense because if 40 degrees is 12, then with an acute, assuming it turns out acute, with an acute triangle, you would expect 10 to be a smaller angle. Okay, so now we know alpha 1. Well, what do we do from there? Well, what we do is we take 180 degrees. We're going to figure out alpha 2 equals 180 degrees minus alpha 1, which, if you do the math in your head, right, is 148 degrees. So alpha 2 equals 148 degrees. Don't have to worry about precision at this point to understand how the problem goes. Now we've got to say, okay, is this a possibility? Can we do this? What you go ahead and do is you take alpha 2 and you add it to what you have before, which is your beta, and you say, your question is it greater than or equal to 180 degrees? If it is greater than or equal to 180 degrees, then you only have one solution. Otherwise, if it's not, then you have two solutions. So let's go ahead and look at that. If we take our beta 2, 148 degrees, and we add 40 degrees, what do we end up with? We end up with 188 degrees. So we're only going to have one solution. And to let you know, I believe the one that I kind of mixed this off of actually had two solutions, which goes to show that I didn't know what we're going to find out here. So we've got one solution. So right now, if you think about it, if we look at our triangle, we now know that this is 40 degrees. What do we know this one is? Do you remember? 32 degrees, right? This is 32 degrees. So now, how do we know what C is, right? And I don't know with this one whether this is permanently scrolling. Can I keep going? We'll see what happens when we get down there. So we now know that This is 32 degrees, this is 40 degrees. How do we figure out that one? Well, a triangle adds up to 180 degrees. So we know that gamma, which I definitely don't do gamma right, is equal to 180 degrees minus alpha minus beta, which equals 180 degrees minus 40 degrees, well, alpha, let's do it in order, 32 degrees minus 40 degrees, which is what? That was 148 to get that. Take another 40 off there. It's going to be, gamma is going to equal 108 degrees, right? So we have 108 degrees up here for gamma. So now, if we want to figure out what C is, it's pretty simple. We already talked about the the law of sines. We know how it all works. So we can basically do the same thing. By the way, another trick that we should put here is that the way they teach it is, even though it's not the answer, just go ahead and, when you have important facts that you figured out, go ahead and put a square around them to keep track of it. So I'm not going to do the alpha 2 because it didn't turn out, but clearly these are pretty important facts. Have we found what we need yet? No, we don't. The good news is we now know what the angle is across from C, but we don't actually know what C is, which is what we're trying to find here. So we already know, let's just go back to what we knew originally. It'll be a bit simpler here. So we know that remember how I told you early on, what you want to do is put whatever you're looking for at the top. So in this case, we want C. So we're going to say C is to sine of gamma equals B to sine of beta, right? The formula then becomes, you want to know C, this means C equals B sine gamma over sine beta, okay? And if you do that, it's going to be C equals, what's B equal to? It's 12 times sine. We're going to go ahead and just use the rough numbers. So we've got sine of gamma, which is 108 degrees, over sine of beta, which is 40 degrees, right? And it is still scrolling, isn't it? Let's see. Let's find this out. See if it keeps going. So C, let's put that in our handy dandy calculator. Again, we're just going to see how close we get. And that says that C is approximately, yeah, and by the way, I should have done this here too. Just as we get this here, these should always be approximates. C is approximately, we'll go to one decimal place on this, 17.8. And I don't know if I said what we are. We're going to say it's meters. Why not? Let's be European about this. We take that, we go like that, we go answer. Okay. Now, I just did this live with you. I didn't know what the solution is going to be. But let's go ahead and see what happens if we do this neat little thing. Notice this trianglecalculator.com. So we go to triangle calculator. Notice I've got A equals 10. Right? Make sure we've got these right. A equals 10. B equals 12. Beta is 40 degrees. Let's go ahead and solve it. See what it says. It says that C is 17 point. Look at that. Look at that right there. Whoops, didn't get the whole highlight here. That's awesome. Look, first time, first video. Isn't this awesome? 17.8. And then you can see it gives you all kinds of other information about it. Notice it only has the one solution, which, to be honest, based on the one that I had derived this off of, I expected two solutions, but it only has one solution. And you can see that solution is 17.794. And we did say approximately 17.8 meters. So either way, what do you guys think? Let me get my video thing up here so I can tell you. What do you think? Was this helpful? How long have I been going on? I mean, I'll edit this some, so I can't tell. It's not telling me. There we are. Before I edited it, it was about 20 minutes. And either way, what do you think? Did this help? If you want to find me, let me bring up my stuff here. You can find me right here. You can email me, Alan Farner. It's alan@math.promo or alan@dataguy.me. So math.promo is where I'm going to put up these kind of videos mainly. Data Guy is, I do metrics and I work with data at work. And all these things tie together nicely. And DataGuy.me starts getting a lot more into processes and stuff. How do we do things better? So think of DevOps, if you've heard of DevOps and you've heard of Agile. Either way, feel free to write me. Again, slap like, please, on it. Subscribe. This is my first video. So if you hate it, be kind, but put it in the comments. I'll learn what you're doing. I'm going to get this stuff going better anyway. Thanks for watching. We'll see you guys again. And, you know, in the comments, tell me what problems you'd like me to work on. Preferably keep it simple, keep it pre-calculus and trigonometry right now. Bye, everybody.